good morning. My name's Tammy Smalley. I'm the Head of Conservation for Lincolnshire Wildlife Trust. On behalf of the South Lincolnshire Water Partnership, which is made up of many organisations, public and private bodies, we applied for undertaking an environmental land management schemes test to DEFRA back in 2019 for South Lincolnshire, and this is the start of that process. So today, this morning, is about inspiring people to think about land management from all sorts of angles. And then we have 3 sessions where we're going to be in conversation with you, gathering your knowledge and intelligence on land management and where you see it going in the future. The first interactive session, and these are all the same, so you only have to book onto one. One is at 3 till 4 today, 3 till 5. God, don't even know. Beth just gave me a Paddington Bear stare. And then we have 2 sessions tomorrow, one at 8 in the morning till 10 in the morning, and then in the early evening tomorrow between 5 and 7 p.m. So hopefully we can capture most of you attending this morning at one of the discussion interactive sessions, which is where you give us your opinions and start to help us inform and co-design what elms should look like. So this morning, please use the chat function. You hover down the bottom of your screen, you'll see the term chat. Just click on that and then you can type in and you can add your questions into the chat. We will have all the speakers first and then a panel and question and answer session with the panel. And then after that question and answer session, I will present on what we're hoping to achieve with this test. But based on the start of the test of COVID-19 and just running recruitment to get lovely Beth and Joe in place, it's already been a challenge. So there we go. I expect it to continue to be a challenge. So we'll crack on. And the first speaker we have today is George Sly, a farmer from Holbeach Marsh area, close to the centre of the universe, which you can see behind me. There we go, the lovely wash, an aerial of it back in the day. Over to you, George. And if the speakers could please turn off their cameras whilst George is presenting.
Okay, you can hear me, Tammy? Yeah.
Can. Okay. And can see you, George. Excellent.
Good. Thank you very much. So yeah, George Sly, we farm very close to Holbeach Marsh, although not on the lovely Holbeach Marsh soil. We're a bit heavier, a bit more inland. And I not only farm, but we also manufacture agricultural machinery, which we sell in the UK and worldwide, which is made here in the Fens. So we farm 300 hectares of mostly grade 2 soils. It's pretty much a ring-fenced farm. I've only been involved in it for nearly 4 years. It was previously contract farm for 17 years. It's a family farm. It's quite a heavy soil, 30 to 50% clay, with a balance of silt and hardly any sand, which has its benefits and has its challenges. It's certainly a powerful, high-yielding soil if you get it right. It's all mostly drained in the 70s, some in the 80s, and the drainage system is certainly tired and needs addressing, which we're looking at. And our farm ranges from half a metre below to half a metre above sea level. When we or when I agreed to sort of take on the farm, we had some soil tests done, and one of the metrics we looked at was organic matter, because it was quite a good thing to start and see, give it sort of a metric of health, if you like, of how much carbon was in the soil. And as you can see, there's some quite big differences on the farm, ranging from 3 to nearly 8% organic matter. When I was presented this map, I sort of hid it from my father and said, what's the history of the farm as to when it was begun arable production? And most of the southerly end was ploughed up in the World War II, and the upper left side, or upper northwest side, was ploughed up in the 80s. So you can see that, although you can't just blame that on heavy tillage, annual cropping of the farm, we've lost 2 to 3 to some places 4% of organic matter in the soil. So that was sort of a quite startling, but also quite good to see that what differences we'd got going on the farm, and how maybe we can look at this again in 2023, 5 years on or 6 years on, and see how different practices we're doing is changing that. I'm just going to talk a bit about what we do on the farm. Not all of this is pictures from our farm, it's more to do with the practices. We're involved with a lot of changing methods of tillage on various crops all over the world, and I'm particularly focusing on vegetable and salad production because it's quite relevant to the Lincolnshire Fens. And it's kind of the assumption with all of those products that we need a highly tilled seed bed with fine tilth, remove all of the previous crop residues, perform deep tillage, beds for drainage, etc., etc. We got involved with a Tasmanian company, which actually has, that area of Tasmania has some quite big similarities to the Fens. It's all flat. It's all flat ground, and there's some similar soil types in places. And they were performing a lot of tillage to produce winter veg, which is obviously relevant to the Fens. And we moved that to a strip tillage system. And by doing that, there was various benefits seen, and that company now farms nearly 6,000 hectares with strip tillage, all on vegetable and salads, and they previously were sort of on a heavy tillage system where they were seeing their soil overall declining, not improving or maintaining itself. And one of the big changes they noticed was water usage. So they do have to irrigate pretty much everything. Even though they're a lot cooler climate, similar climate to us in terms of it's very, very different to mainland Australia. They saw at least a 50% reduction in the use of water, which to them, with the cost of water is very expensive, was a huge impact on the overall productivity. And actually the retailers buying it for them used that 50% water saving in marketing of the product to try and achieve a higher price. So it was quite an interesting project, because what the farmer was changing, the retailer was kind of backing and seeing that through to the customer, to be more environmentally sustainable food production and less water usage. And that was quite relevant to this presentation as to talks on water, or this meeting about water usage and water shortages in the UK, and we are in one of the driest parts of the UK. So the benefits of strip till, you're only really working between 30 or 25 to 45% of the field. The rest of it you don't move. You have a much better retention of soil moisture, and much easier harvesting conditions. You've generally got an increased infiltration rate of rainfall, better drainage through lower soil compaction, deeper root development, and general overall better quality. They've not seen any yield drop from reducing tillage, neither have they seen significant yield increases. So it's basically been a cost and environmental win, and I wouldn't comfortable to sit here and say that they've doubled their yields, but they've certainly maintained yields and reduced costs considerably. This picture was actually, I was there when this picture was taken, and 2 fields side by side, and they had a hot day with quite a high wind, and you can see where they've left residue or a cover crop between the strip rows. The wind speed at crop level is much slower, and there's more retained soil moisture, so which means that the soil is not blowing and kind of shot blasting the plants. And overall, they should be seeing like a net carbon increase through the system in the soil rather than a net drop. So we are involved in some UK operations with strip till and vegetables and salads, Riviera Produce down in Cornwall, Barfoot's in Sussex, G's/Shropshire's here on the Fen, and it's certainly growing in popularity. There's a lot being done in the world about less tillage and improving soil health and more sustainable cereal production, but we're quite interested in the fresh produce market because it's kind of a tough nut to crack, and there's a lot of opportunity for us as an equipment maker, but I'm also interested in it as a farmer, and on how we could integrate that. So we have through the companies we've been supplying, we have had various interactions with retailers as to how could more sustainable production of the food actually be educated to the consumer in the shops. Strip till gives a lot better supporting structure for the ground. So this picture on the left of this tractor was taken a couple of years ago in Lincolnshire in a veg field. Nobody really wants that. The farmer doesn't want it. The soil is getting absolutely hammered. And although it was a very tough winter, we've kind of created the problem ourselves. When you do less tillage, you have this kind of natural supporting structure to support the machines. And then we have a more level field. We've not damaged the structure so much. We don't have as much cost to establish the following crop. This is just a slide of ideas we've discussed with various different companies or it was actually presented to me, whereby they're considering food labelling, where when we all know when we go in the supermarket, if we see red on sugar and saturates and fat, it's kind of deemed less healthy for you. But also, could we consider CO2 labelling of food, whereby it's green, yellow or red? That might be whether it comes from Lincolnshire or it's flown in from Kenya or Israel or wherever it might come from. We can start to benefit producers that are farming in a more sustainable way. So I've done various vegetable tests on my own farm. I've put cauliflower into cover crops. I've done different inter-row companions between cauliflower, kale and broccoli. And we've tried different mechanical methods of doing that and how to control the weeds, how to reduce nitrogen, how to reduce herbicides, and how to generally grow that fresh produce, or to try to grow directly consumable human calories whilst improving soil instead of degrading it. We grew also some squash and pumpkins with various successes and failures. We tried to grow like a nitrogen fixing clover and grow pumpkins and squash on top of it using a strip tillage system, which was really successful. So we had an equivalent yield to a commercial grower on one particular plot, and better skin finish, and we didn't apply any herbicides or nitrogen whatsoever. I'd say the main limitations of like less till and veg and salads. My grandfather grew vegetable on our farm and took it on his lorry to Spalding and sold it to his local customers. That kind of market and demand has completely disappeared, really, because we all go to a major retailer for that product rather than a local sales outlet. So it's quite difficult, and it's very high output. You've got companies turning millions in Spalding and making less than 1% return, and that's all the cost of the soil. So it's looking at how we could, what systems we could put in place and how we could better educate the consumer to maybe choose a little bit differently. In terms of this is my own farm. I'm using strip till to grow maize, and I was growing sugar beet. And I've pretty much removed the need for herbicides in that crop and reduced the nitrogen by around 40%. So I grow a cover crop to the side of where I'm going to put a cash crop. So in the winter, there's a cover in the field, but I've kind of still got my cultivated strip to put my cash crop in the spring. And we're trying to fix nitrogen and improve the soil health and soil structure, and then put the cash crop in its place. I'm also playing with the risk if glyphosate's removed from us in years to come. So this kind of system is where we're only cultivating this area. We're trying to maintain a constant companion in this area and build residue, build soil carbon, look after the soil, and only crop, only work the field where we're going to establish the crop. So in terms of nitrogen and nitrates in water and et cetera, nitrogen is something that I think will be heavily regulated in the future. It takes 16,000 kilowatt hours to make a ton of it, which if ever the public realise how much energy goes into the stuff and how badly we use it, I am certain it will be heavily restricted. About 42% of the nitrogen we apply never comes off in a crop yield. It's lost. So we're only just about 50% efficient on something that is more energy consuming than a Boeing jet in the air. So it's a vastly inefficient process in agriculture is the use of nitrogen. We're trying to be so by next or 2023 we shouldn't broadcast apply any nitrogen, and I'm trying to work out how we could get to be nitrogen free by 2030. Looking at that, we've done different trials with clover. So for those of you who don't know, clover is part of a group of plants which have the ability to pull nitrogen out of the air and nodulate it on their roots, and then potentially pass that on to crops that we want to give nitrogen to, which would then negate the need for consuming lots of natural gas, refining it in Qatar, hauling it all the way here, and then broadcasting it on our field or wherever it might be made, which is a hugely energy intensive process. I've had various successes and various failures, really encouraging advances in the last sort of 12 months, more to do with technology of how to stress the clover. When you stress that clover, it tends to nodulate and pass the nitrogen on. It's kind of like its will to the next crop, if you like. It gifts its nitrogen. If it's a healthy plant, it tends not to gift so much to other plants around it. And so we've been playing with different ways of stressing that clover to pass it to the next crop. And in this slide, you can see we've established a white clover, and we've then tried stressing it and see how much of that nitrogen is passed to a maize crop, and with various successes and failures. And you only kind of get one chance a year to try this stuff in agriculture, so you don't move forward that quickly, but we're trying. Lucky part of what I do, I have a lot of technology available to us. So we build these maps every year of our fields. We have special sensors on our machines which scan the soil whenever we go in the field. So we're monitoring soil moisture, organic matter, the cation exchange, temperature, and residue in the field. So we've got this kind of lens into what we're doing, where we can watch, are we going in a good direction or a bad direction, and how do things impact our outputs. And these maps that we have, we can look at the soil carbon, and we can change stuff like seed rates or seed type, seed varieties based on good or bad parts of the field. So this technology is really coming on in the world, where you can focus your inputs or vary your seed rates and populations depending on the healthier or poorer parts of your field. So it really is a huge efficiency gain in what we're doing. And our most recent sort of move on the farm is agroforestry. For those of you who don't know, that's simply growing trees in a field. We have alleys or lanes of trees, so we have 24 meters of actual arable crop, and then we have at the moment 28 meters between the actual tree lines. Most people, when I say about agroforestry, they initially will say, how will the trees will kill your crop, how is that going to pay, etc., etc. Our particular system has been designed where I believe the trees will output more per hectare than the arable crops in between them, so they're not a cost, they're more of a, they've got to produce and they've got to pay their way. We focused on nut production. Most people think I'm barking mad when I say I'm growing walnuts or hazels in the Lincolnshire Fens, but actually the climate relatively suits them. There's nobody else doing it, which gives us a great opportunity. And the nice thing about growing trees like this, if somebody else wants to jump on board, and they've still got to wait the years to get the trees through. But all of these will be mechanically harvested, and we aim to sort of market the first British grown carbon negative nuts. And the nut varieties and species we've chosen have about 50% of the protein of a chicken breast. So from a nutritional point of view, our healthy calorific output per hectare should be between 3 and 4 times what we would be doing if we were outputting just annual cereals. So actually we're producing kind of farming on a 3-dimensional plane and producing far more nutrition per hectare for humans than we would be what we're doing now. And we plan to sort of coppice some of the trees, use the prunings, use the nut shells when we crack them, through to use that energy for heat and for drying the products. Currently we have 15 hectares. We are moving through to probably up to 90 hectares over 4 years, and then we'll sort of see where we go from there. We may end up doing the whole farm, and we will be not just in nuts then, but also some fruit and timber products. Our mix is confectionery hazelnuts. So these are hazelnuts that you would actually used in like Ferrero for confectionery, so they really taste nice. And the walnut varieties we've took for direct consumption, if that makes sense. But the whole system looks a bit of a mishmash because it's not a monocrop of hazels, it's not a monocrop of walnuts, it's a mix and match of different tree species to house insects, birds, fix nitrogen, improve soil health. We've put different tree species in the field lows where they would prefer to be in a sort of a heavier clay, wetter soil, and different higher productivity trees on the silt hills where the soil's more productive. So when they grow, it will look a bit of a mess, which some people don't like, but nature's a mess if you leave it alone anyway. So I'm trying not to interfere with that too much and more create a biodiverse sort of farming system. And the other thing is I think there will be like agro-eco tourism opportunities, even if the Lincolnshire, well, Gedney Hill is not renowned for its tourism by any means, but it will create a landscape where the farm should have different outlets in 10 or 20 years to widen our kind of income. And that's me done. Thank you very much. We are on social media if you want to follow what we're doing, and I'll be here for any questions.
Thank you, George. If you could just stop sharing, which I'm sure you're in the process of doing, that would be super. Thanks, George, very much. If you could turn your camera off, that would be lovely. I'm now going to introduce Becky Carter and Kelly Hewson-Fisher from Anglian Water, who are going to do a joint act on a presentation this morning. Both ladies are catchment advisors for Anglian Water, and I have the pleasure of working with them both. Over to you, Becky.
Thank you very much, Tammy. I'll just share my screen, and then we can get started. Can everyone see that okay? Yeah, brilliant. Well, good morning, everyone. Kelly and I are going to explain our sediment barrier trials in North Lincolnshire this year. This was a partnership project between Anglian Water, Lincolnshire Chalk Streams, with the in-kind donation of the sediment barrier from the University of Lincoln. The soil and cultivation expert, Philip Wright, was also involved in suggesting specific ways to each of the host farmers that were involved in the trial to manage soil movement on their fields based on the findings from our results. In my 2 slides today are going to give you a background the trial and kind of explain how we got to the methodology which we did use in the end. The first of these is a sediment barrier trial in the Kringle Brook catchment near Grantham of Leicestershire area, so it's mainly mixed with combinable crops and some sheep and some livestock. The fields are heavily sloping, but the land isn't good enough really to grow kind of potatoes or sugar beet. So it really did used to be kind of a wheat rape a growing area really. Anglian Water had been working to improve water quality in this catchment over the last couple of years through a big European project with the University of Lincoln called Fairway. This project has shown that sedimentation, which takes with it phosphorus and pesticides, is an issue that affects the water quality of the Kringle Brook, which is the main brook that runs through this catchment, and also the ecological health of that water. Some of the sediment is kind of natural sedimentation due to scouring of the bank of the Kringle Brook in periods of high rainfall. And you can see that because it tends to be quite low in the spring and then it goes into flood over winter, which we saw this year. But parts of the sediment loss into the Kringle does come from the fields itself because they are quite heavily sloping and most of them do kind of slope down towards the Kringle Brook. So one way to kind of tackle that problem was having a look at oblique drilling, and this was done in conjunction with Philip Wright, who advised on this trial. So this trial compared two different fields that were both next to each other, drilled with the same crop within a day of each other, that both sloped down towards the Kringle Brook. On the left-hand side, you can see the tram lines in blue, which run kind of horizontal, and then the drilling, the direction of the drilling at a 45-degree angle to that. And the benefit of that is basically it puts a crop into those tram lines to help intercept some of the soil and water loss and direct it back into the crop. That was then compared on the right-hand side, so that just shows the kind of conventional direction of drilling. So it's down the slope along the tram lines, and then it kind of goes towards the Kringle Brook area. A sediment barrier was installed on both of the fields in areas where surface and sediment loss was likely. This was identified by going out in the fields during wet weather and kind of seeing where all the water and the soil runs, and also with help from Philip Wright. And those are shown by the red line on both of those maps. Generally, it was just where the field was lower and it kind of naturally sloped down. So at the bottom there, you can see a picture of the sediment barrier, and that's where it naturally sloped down before it went into the Kringle. The sediment barrier is an idea brought over from the construction industry to reduce soil movement on construction sites. So it basically just acts as a physical barrier to try and stop soil movement. In terms of results from the trial, we didn't see much soil movement actually at the sediment barrier, which was a bit disappointing, but something that's mirrored in our North Links trials too. But what we did find actually was the benefit of oblique drilling. So where in the field that did have the oblique drilling, there was less water movement visually down the tram lines, and that was assessed by Philip Wright, but also better soil structure because those tram lines had the crop going through and had roots. The other benefit of this trial is that we learned the methodology behind how to set up a sediment barrier, which really helped this year. So that's more in terms of the practicalities of how to go about putting it up. The second way previous trials informed our current ones in North Lincolnshire was a trial set up in the River Kim catchment in Cambridgeshire. The cropping in the Cambridgeshire area is kind of similar to what everyone expects, so it's mainly arable, with tends to be a high blackgrass pressure. And this high blackgrass pressure causes an issue both for farmers in terms of yield loss and also money spent on herbicides, but also us as a water company, as we tend to see quite high levels of blackgrass herbicides coming into our water treatment works. And this was particularly shown this year where we had high levels of curb or pyrazimide at our Grantham treatment works. So this trial was kind of used as a bit of a demo for the VI Auto campaign. So it basically asked the farmers in this catchment as a bit of a group, what practical and voluntary measures do you think of you might want to do to reduce the risk of auto herbicides getting into water? Lots of different ideas were put forward, but one of the ones that was taken forward in this particular trial was to test rotational buffer strips, which basically moved around the farm along with the oilseed rape. Now in this catchment, like this idea worked well because not everyone at this time was keen to go into stewardship. So there were some fields with oilseed rape that just had the 1 metre cross compliance strip against the ditch and didn't have any kind of permanent grass buffer strips at all. So this was kind of a halfway house idea. So could you put a temporary buffer strip in just against the oilseed rape to try and reduce that risk? So to test whether this approach would work or not, a catch pit was installed in 6 places in one of the oilseed rape fields. So 3 were at the edge of the field, so the crop is shown in the bottom, so it's quite a thick, good crop of oilseed rape. And 3 catch pits were installed just at the edge of that crop. And then 3 were installed at the edge of the temporary buffer strip, just as it's about to go into the dike, which is shown in the 2 other pictures. The catch pit itself is a kind of 2 metre long pit dug into the ground, which is then lined with plastic and then covered with a plastic liner. The purpose of this really is just to make sure that the catch pit itself is just capturing the surface runoff from that field, so it isn't capturing rainfall in it. So it just captures the water and the sediment. What was really interesting about this trial, and why I think science is so exciting actually, was that this design was a novel design. It hadn't been done in the field before. We had read papers where they kind of talked about, you know, in universities how to kind of capture soil and sediment runoff, and a lot of them were very costly and very expensive. So it didn't always lend itself to being that practical. Well, this was quite a cheap and innovative way to try and measure this in real time. The results of the trial showed high levels of curb, which is pyrazamide, and carbetamide, which were seen outside of the application window. So like, for example, in this example, in March, rather than kind of over the winter when it's normally applied. This suggests that these herbicides are persistent and kind of stick around on the field. And then when rainfall is enough, then it moves with the soil and rainfall down the field and then into the catch pit in this case, but I guess also into the dike if the catch pits it wasn't there. Now what this shows is a legacy effect of these herbicides, and we sometimes do see this where we have herbicides that come through that are outside of the application window, and this was something that was shown in the North Links trial this year. But also because Phil's on the course, I want to mention the Loddington trial. So we've got a clethodim trial having a look at 14 different blackgrass treatments for oilseed rape. And what we found at a site visit last week was that where the curb had been applied to one plot, because of the high level of rainfall, it had actually moved that curb from that plot where it had been applied onto the control strip, and half of the control strip was taken out. So all the blackgrass in the control strip was taken out by that curb movement, and then the other half of the plot where the curb hadn't yet moved to had a blanket of blackgrass. So it does show actually that because curb is more soluble and it can and does move, it doesn't just stay on the field. It does have that risk of moving into watercourses, which obviously causes also a problem as a water company. What was also good about this trial is that it showed quite high levels of herbicide seen. So that's the 25 or almost 25 micrograms per litre of carbetamide against the legal limit of 0.1. So really, really huge levels. And these were similar levels that were seen in our sediment barrier trials this year, which I think adds support and strength to our data. Over to you, Kelly.
Brilliant, thank you, Becky. Yep, that's great. That really sets the scene for the sediment barrier in the catch pit trial that we did in another catchment in Lincolnshire. So we set up 3 sediment barriers and catch pits in 3 separate fields. If you could move to the next slide, please, Becky. So I'm just going to give you a bit of background to each of these sites, and then we'll have a look at the results that we found from the water that we captured into the catch pit and the sediment that we collected from the barrier. So the current cropping in this field is winter barley. The previous cropping was rotation of beans, well, spring barley, winter wheat, and then beans. It's clay loam at the top, running to a sandy loam further down the field. There was quite a few cultivations, which you can see there. The sediment barrier was actually placed on the right-hand side of the picture at the bottom, about halfway down alongside the wood. And the catch pit was actually placed on the left-hand side at the bottom of the first tram line, therefore trying to capture any water movement from that tram line itself. What's interesting across all three sites is the pesticides that we identified or that were detected within the water captured within the catch pit were very similar. The prosulfocarb in the Defy, the flufenicet, and also glyphosate. The rainfall across all three catchments was similar between the period that we set up this trial, which was autumn last year, so autumn 2020, until March this year, and was about 230 mils across the sites. The picture on the right-hand side of your screen there is the catch pit. So you can see, as I mentioned, we placed it on the bottom of a tram line. So you can see the water and the sediment that's actually run down that tram line and is running into the catch pit. And as Becky mentioned, if that catch pit wasn't there capturing that, and that was a ditch or a water course, that sediment and that water would then be running into that ditch or water course. Yeah, next slide, please, Becky. So the results from this site, this first site, as I mentioned, flufenicet, prosulfocarb, and glyphosate were all detected in the water that we captured in the catch pit. So as Becky mentioned, the drinking water standard limit is 0.1 micrograms per litre for any individual pesticide. So here we can see flufenicet above those levels continually across the sampling period from October to February this year. So at 10.14 flufenicet, but also we can see there glyphosate as well and some of the prosulfocarb. So what we do know, as Becky mentioned from her trial, is that when we have water moving down the tram lines across the field in any way, shape or form, it can take with it pesticides. So they're not in the field doing the job, but equally they're potentially causing a headache for others as well. Next slide, please, Becky. So the next site was a different crop. So we had oilseed rape in this field. It's a rotation of wheat and oilseed rape. It's a similar soil type. So it's clay loam moving to a sandy clay loam. And at the bottom of this field, we do have another water course there. Direct drill here, there was no preems applied, but looking at it, it's oilseed rape. It's really interesting seeing the results, which I'll show you in a moment. So yeah, I think there's two pictures there. Next, Beck. So this picture here, the first one that came up is the sediment barrier you can see, and you can see where we placed the catch pit. Within this field, we actually placed this catch pit in front of the sediment barrier, so it wasn't on the bottom of a tram line in this field. And really what we wanted to do is see if the overland flow maps that we looked at were correct in showing where the water would flow across that field. So where we've placed the catch pit and the sediment barrier would ordinarily be where the flow from the field would come into it. Behind the sediment barrier, where you can just start to see the trees, that's where the beck runs at the bottom of that field. So anything running off that field could potentially run into the beck at the bottom of the field. Next slide, please, Beck. So the results here, as I mentioned, we've seen flufenicet, prosulfocarb, and glyphosate across all three sites. And what's really interesting here is that prosulfocarb hasn't been used according to the farmer for a number of seasons. So as Becky mentioned about the legacy effect of some of the pesticides that we do see, what this trial has proved is that those pesticides do hang around, and when we do get those periods of rainfall, then they do move within the field and potentially move into water courses where then we detect them. So for sometimes it can be a real head scratcher for ourselves, where we're sort of advised of pesticides that we're seeing in our raw waters, but we're wondering where they're coming from because it isn't the application window for those pesticides. So this trial really is valuable to us in starting to understand that. So flufenicet still above the 0.1, as I mentioned, prosulfocarb there, and glyphosate nearly at 4. Next slide, please, Beck. Oh, I think there's another thing that'll come up here. Yeah, so what was really interesting on this trial, oilseed rape, so propyzamide and quinmarac were used. Propyzamide at 633 micrograms per litre coming in, and quinmarac at 44.38 micrograms per litre. So Becky mentioned the carbetamide in the trial that Becky was involved with at 24 micrograms per litre. So we can see really huge levels of these pesticides, coming through in that catch pit where we're detecting them. We'll talk about that again in just one moment. Next slide, please, Beck. So running through these, site 3, this is a winter wheat field. It was oilseed rape. It's a different soil type, chalky wold, and it's direct drilled with a cash crop. Pre-EMS, it did have the flufenicet. So again, remembering that when we look at the results. So this was the sediment barrier and the catch pit. Again, this was cited from where we looked at maps and saw that overland flow would occur in the field rather than at the bottom of a tram line. Next picture, Beck. Or next slide, sorry. So the results, we got some flufenicet in there at 1.4 micrograms per litre, a little bit of prosulfocarb that hadn't been used in this crop, and the glyphosate. Just picking up on the different results of the different sites. So site 1, where it was quite heavily cultivated, we saw the flufenicet levels at 10.14, and site 3, which was direct drilled into a cover crop, we saw those levels at just below 0.2. So what's really interesting is, the difference in those levels, in those results. Can that be attributed to the cultivations, to the health of the soil? Going back to George's sort of slides and messages from there, could we attribute that to those reasons? Next slide, please, Beck. Just whipping through these slides here, what we also measured in the catch pit is total suspended solids, so sediment movement within the water itself. And what we could see that there were quite high levels across all 3 sites here. So what they say is anything over 40 milligrams per litre of total suspended solids would give us a cloudy look to it. So it's how turbid, how cloudy that water is. With reference to the amount of suspended solids in it. So all of the sites were above those figures. I think there's another one here, Beck, if you can just click on. So the interesting thing here is site 2, we have total suspended solids at a peak of 4,660 milligrams per litre. And on the same day, that was when the propyzamide and the quinmarac spiked. So what's interesting is the reasoning behind this. And I think it's really looking at application methods when you're in the fields and looking at those buffer strips that we can put in place alongside sensitive areas such as watercourses. Could this actually have been from the tractor, the sprayer, actually just being too close to the catch pit, and the sediment being washed into the catch pit itself? We don't know the exact reason for this, but certainly it's something that, with all of these high levels, something we need to look at going forward. Next slide, please, Beck. Just got a couple left. So what we also did was analyze the soil. So as Becky mentioned, with the sediment barrier, we didn't see the amount of sediment gathered up near the sediment barrier as we thought we might. But what we did do is take some soil and send it off for analysis that was at the barrier and also in the middle of the field. So A in each of the sites is at the barrier and B is in the middle of the field. And what we didn't really see too much of a difference. And I think the interesting thing with that going forward when we look at phosphate as well is, did we have more occurrence of soil moving as a bulk rather than soil particulates moving within the field? What we can see here though is glyphosate does move with the soil. So looking at pesticides moving in the water, we're also seeing the pesticides moving when the soil moves as well. Next slide, please, Beck. So this one, so this one is just looking at the phosphorus movement in the soil, and again, just making the same comments as are made with the glyphosate and the pesticides. What we're seeing here is as soil is moving, so is phosphorus moving. You know, phosphorus binds to soil, and when we see that movement in a field, either down a tram line or just across a field, due to soil type, due to cropping, due to soil health, we need to look at mitigation measures in order to reduce that and to keep that soil in the field. Next slide, please, Beck. This is my last slide, and I think this is really interesting in terms of looking at the feedback from the 3 farmers who have been involved in this trial. And I think what's interesting is what changes they have stated that they're going to make following this trial themselves. So the comments in bold, I think, are really interesting. So one of them, you know, we need to be more proactive and looking at options going forward, whether ELMS can be part of that and be part of the plan and the discussions and the progression going forward. From site 2, the trial results were fascinating, and I didn't appreciate how much water travel we would have. And that was off the site where we didn't set the catch pit at the bottom of a tram line, but we set it where we knew, or we hoped, the maps were correct in showing us where the overland flow was. And for site 3, that was where we saw less pesticides coming off with the water, where it was direct drilled into a cover crop, and where the farm really had focused over the last couple of years on improving soil health. And their comment being, it's nice to have the validation from the trial that what we are doing is helping and working, but they're still looking at what more they can do to try and reduce these soil and water losses from fields. Thank you very much.
Thanks, Kelly and Becky. That's really interesting. In-field trials with really great learning that we may want to consider when we think about what public goods in the South Lincolnshire Fens should be prioritised through the ELMS test and the information we feed back to DEFRA. So now we have Phil, Jarvis, and I am going to screen share for him. So just bear with me a minute, everybody, because of course, technology sometimes likes to be a naughty pixie. And today we have had naughty pixiness. So Phil worked on the Allerton project, and I'll let him now tell me when he wants to move forward, and I'll put myself back on. Oh no, I don't think I can I? So over to you, Phil.
Right, thank you very much, and good morning. And my title is Good Soils, and there's a lot of resonance with what George said. The first thing I would say as well about good soils is it can mean a lot of different things to different people, and it can show itself in different ways. The first thing I wanted to just talk about was the Allerton project, the Game and Wildlife Conservation Trust demonstration farm. And really, you know, I could show you quite a few more graphs and pictures and graphs and tables. What I'm going to concentrate on is some principles. And firstly, the Allerton project is combining productive farming with wildlife conservation, researching that interaction, and also disseminating that the results for the benefits of other people. So if we could move on, please, Tammy. So if we look at our farming approach, wide rotation, soil cover, reduced cultivations, livestock, trying to reduce our inputs, looking at carbon and biodiversity. And a term at the bottom, which I noticed George sort of avoided using, is term regenerative agriculture, which seems to be gathering momentum. And a lot of people saying, well, I don't like that term anymore. I think any term that becomes popular suddenly becomes, you know, people like to shy away from it. I think innovative agroecological approach, regenerative agriculture, whichever, and there is no definite definition of it, can mean a lot of things to a lot of people. And I think George has shown the innovation that he's got on his farm, trying to address the problems. And I would think on our farming approach, where we're looking at on heavier land, I was interested, George's farm plus and minus 0.5 metre. Our farm is plus and minus, well, it's the lowest point is 150 metres above sea level, up to nearly 200 metres above sea level, within about 300 metres of each other. So some quite big slopes. And I think one of the things I want to pick up on is the second one down is soil cover. And I think if we're not aware of changing weather patterns, looking after our soils is crucial, because the link between soil and water is really strong, and looking after that and changing our systems to do that is going to be really important in the future. Yes, please, next slide. So this soil doesn't exist, by the way. This is a hypothetical soil. It might exist at some times on some farm somewhere, but I reckon if you tried to go and find that soil, you'd be quite limited at where it was, because at different times of the year it will have different permutations of that. But this is a sort of what it's trying to say is that, you know, soils, whether they need to have air, need to have water, need to have some mineral matter in them, need to have organic matter, and they need to have some living life in them as well. Now, sometimes living life, if it's beneficial, is great, but in certain production systems, and those of you that are producing high quality produce, you know, a lot of biology and the wrong biology and can cause problems with product quality as well. But I think for broader acre crops and things that are grown above the land, you know, more activity going on the soil, better you know, air and water development, for allowing development of roots, is really important. Yes, please, Tammy. So, and George alluded to his soils. Here's a field from Loddington, 30% clay, surprisingly 50% silt, although I'm sometimes think that clay really does have a big influence. You only need a small amount of clay for soils to start showing those properties. But I think knowing the texture of your soil, and a lot of you will be familiar with this sort of flow chart about determining your soil, is really important, because it tells you the capacity of your soil to exchange nutrients. It lets you know about its potential capacity for what organic matters you can get to as well. You know, the sandier your soil, probably the more you're going to struggle to get build organic matters, or you'll need to feed your soil or grow more organic matter, because if it's the soil more air in it, and there's more mineralization and oxidization, and it may well not. And also cultivations in some cases, which means some of that soil ends up disappearing, and we might pick up on that, especially around high organic matter soils as well. So next slide, please. And you know, George talked about structure and water storage, and I think one of the things I'd like to pick up on is that the farming systems that we might have developed in the past, and we've seen examples from, you know, leaving soils bare where water disappears out of our ground. You know, we've seen the last couple of years, you know, soils really wet until the beginning of March, and then within 4 or 5 weeks, we're wishing that we had a bit more water. Where's our water gone? Has it run off the surface? Has it gone through our drains, or are we storing it in our soil? And I think if we are going to have this change in events, we've got to try and find some way of capturing water when it's flowing, holding it in the soil and so it's available to plants for much longer in the year, because our weather systems perhaps aren't reliant. So I think water storage within soil is going to be a real key issue for a number of growers and a number of crops. Yes, please. And we you know, Kelly has picked up on some of these points around erosion, and you know, we should remember that it's not just water as well, it's wind that can be an issue, and that's taking soil and it's blowing, and you know, on flat land that can be a real issue. But you know, not protecting soils and losing the shop floor off our fields, and with it plant protection products, and with it nutrients, really needs to be in our fields. So I think, you know, efforts to keep the soil covered up, and it's one of the things that we need to do much better at Loddington. We need to get much more soil cover throughout the year, so we're not exposing our soils to high temperatures, excess rainfall. You know, rainfall droplet size is increasing by 5-fold. So a 1 mil droplet to a 5 mil droplet has an almost, well, it's about 500 times more impact of that heavy rainfall hitting the soil. So protecting it with soil armor is really important. And of course, the other things there, like flooding of the highways and muddy runoff, you know, there are other issues that then with water pollution and problems with traffic, etc. That are things that as farmers, we need to find a better way of keeping that soil in our fields with appropriate cropping systems. And just because we've done something for the last 40 or 50 years doesn't mean to say that it's going to be right for the next 40 or 50. But of course, we've got to try and find solutions. Yes, please, Tammy. So, you know, looking at, you know, some of the things that we've traditionally measured in the past, from nitrate, phosphate, potassium, and pH, where are we getting them from? How are we cycling them in our soils? For example, I know that in our own soils here on clay soils, we have between 8 and 12 tons of phosphate in there. But trying to get it off the soil cation exchange site and into the plant is proving really, really challenging. So how can we have better use of nitrogen, for example? So nitrogen use efficiency is really going to be key, because we want to keep that nitrogen in our field, in the crop, and not lose it and then potentially cause problems elsewhere. Carbon, we've talked about carbon. Carbon's probably going to be the new crop of the future. How we go about farming as well. You know, our carbon sometimes leaves the field as straw or produce, or leaves in livestock. And it may well be in the future that actually society would rather us put the carbon back in the soil to sequester that carbon dioxide. And we've got to therefore try and find ways of A, producing food, but B, meeting that societal demand, whilst making sure there's an economic model to do so. And cation exchange sites are important as well, because that's where the exchange of nutrients goes on in the soil. And that goes to make up the whole picture. And also, these chemical and biological processes within good soil or good soil functionality, they're inextricably linked. You know, just because it's a biological process going on, it's actually some chemical reactions going on as well. And I think in the future, what are we going to be measuring? Because I fear we may well get hung up on measuring organic matter and soil carbon and developing massive tests and lots of resource to try and do that. Whereas we may want to look at the bacteria fungal relationship in our soils and encourage the practices that are best for those individual farms that perhaps want a more functioning soil with better soil biological activity, rather than those soils which may well have a number of those things going on, but it's not always in their interest to encourage. I mean, we all talk about earthworms as being great. And in fact, if we go on to the next slide, for a number of soils, earthworms are great. You know, they can recycle nutrients. They can open up nutrients to be recycled by other things in our soil. You know, it can be broken down by protozoa, bacteria, nematodes, and a whole host of other things and smaller microfauna in our soils. And it can help with drainage, and it can help. But sometimes the biology that comes along with things may not be so advantageous, things like slugs and other pests of crops. So we need to be very careful about what we're advocating as regards systems for a number of production systems, and making sure that government realize that within the industry, it's not just cereals and broadacre and livestock, but the horticulture industry, very highly productive, and it has to have ways of encouraging the sorts of things that you've heard from George earlier on. Yes, please, if we can go to the next slide. So just talking about cultivation systems, and most of the work at Loddington that we've done will show that where we've done reduced cultivation and put this more regenerative system in, we get better water quality, we get better greenhouse gases reduction in them, we have less nutrients leaving the field, and we have more biodiversity on the fields. What we have to try and do that with is make sure that they're consistent with our yields and our economic margin, and finding that economic model is one that's really is quite challenging for us at the moment on grade 3B/4 land on some of it, which probably many years ago would have been grassland, and much of it will be going back to grass. But I think I'm reminded by a former AHDB monitor farm, that I'm not running a hotel for microbes and organic matter. I want them to come along and help us pay some bills. So that's quite an interesting conversation. So we'll move on to the next slide, please, Tammy. And of course, you know, cultivation systems vary. You know, there will be ploughing, there will be min till, there will be light till. And as George has alluded to again, you've talked about strip tillage. And so innovating around vegetables and around sugar beet. And, you know, I think innovation and technology will come in the future, but we need to see that we have some options within a sustainable farming incentive and ELMS going forward. That if we want farmers to change, then we have to give them incentives. We have to actually show best practice. And I mean, a number of farmers will pick up on this stuff, but you know, in the past, history would tell us that if you bring in policy, whether it be the Common Agricultural Policy, farmers are businessmen as well, and they will follow where you set the trend. So if you want to take farmers on a journey, and administrators and the government, then we need to put in place things that appeal to all the sectors, and things that are practically implementable as well. So the next one as well, please. So I just mentioned things about drainage, and you know, as on our farm, we've got some much drainage. Probably 25 to 30% of the farm was drained in the early 90s, but much of the farm was drained before that, and there is a lot of silt in our drains, and they are beginning to cause problems for us. So the dilemma here is, how do we drain heavy soils but not lead to flooding, lead to excess nutrients? So smart drainage schemes, climate, I mean, with possibly reservoirs or biodiversity habitats next to reservoirs at the corner of fields, you know, whereby we get balancing ponds that can drain a field but not impact on flow, and can act as sediment traps as well, may well be some answer to the problems. But just turning a blind eye to it and saying, no, we don't want any drainage in the future, is not really going to help us with the increase in population, you know, from 7 to 10 billion people worldwide. And we often are comparing figures from the 70s about the state of our biodiversity. We have to realize as well that there are actually 12 million more people in the United Kingdom from that period from 1970s now. And we have to address it, and we have to get that balance right between environmental responsibility and food, for sustainable food production, with food that's produced in this country potentially because of its environmental footprint. There's no point us increasing, if we want to be a global leader, as the 25-year environment plan states, and really that does mean about not having unintended consequences because of the trade system that we set up. So if we move on to the next one, please. I won't dwell on this too much. You know, some soils might need more organic matter, and there are a whole host of things about how you can increase organic matter. It's as much to do with not losing your organic matter. You know, for example, you know, soils that are shrinking with high organic matters, you know, is there potential for re-wetting them, for making them last longer? Is there an economic model around how we might do that? Next slide, please. And looking as well at carbon nitrogen ratios, with looking at what we want in our soils, especially with cereals, which is in mainly in our area where crops that we're growing. But you can see there the top 6 or 7 of those things are all in the region of higher nitrogen content, higher protein content, easily broken down by microorganisms. And you know, there are a number of rotations that we've developed which are in that region of oat straw, wheat straw, cereal based. I put paper waste in there as well to highlight the amount of carbon in there. And of course, that takes a long time to break down. But a balance of those things is what we're probably going to need. Things that will break things down, but also that oat straw, wheat straw, and wood in our soil, or carbon in our soil, is a food source for that microbial activity. And it's also the sort of carbon that we want to keep in our soils, because very high protein, very highly digestible organic matter, nitrogen crops break down very quickly, actually also release greenhouse gases. So we need to get a balance of keeping them in. So it's not a increase your organic matter and it'll be a straight line. It may well be a staircase and an escalator to get there. So next slide, please. So my final few slides are around soil management plans and really looking at how we might deal with those. So, you know, I think it's looking after our soils is key. And I think the biggest influence we have is what we do in the field. So, you know, address all those problems about tram lines, about companion cropping, cover cropping, and look at how you can affect what goes on in your field first, inside the field. Mitigation, so barriers, silt traps, possibly barriers across field like beetle banks, or etc. like that, are the things that should be considered after we've done as much as we can within our field. And then perhaps joining up with farmers. So this is why facilitation funds and groups of farmers getting together have a huge amount of impact, so that they can share knowledge and gain experience from each other about how to affect. And also potentially, you know, talking about marketing crops as well. You know, farmers working together over environmental matters, whether it be water or biodiversity, have a fantastic provenance to market products on the back of as well. So that's worth looking at as well. So if you move on, please, and just cover crops will have been mentioned a number of times, growing in popularity, and it can have fantastic impacts on erosion and fertility and soil structure. They don't come without challenges, and if I move on to the next slide, you'll see that you know, there are some great things to happen with cover crops, but you know, you can suppress weeds, it can encourage more biodiversity, but there are also some other challenges, which if we just move on one more click, you know, there are costs associated, there are green bridges, spring seabeds on heavy soils can be challenging, as can grazing livestock as well on them, and there can be certain crop allelopathy. So, you know, it needs careful management. So be aware, cover crops may be suitable in some places, but not always. And the next slide, please, Tammy, is to really look at, you know, are we growing appropriate crops? You know, are we fixing our drains? Have we put maybe infield buffers around some of our infield areas? You know, things like beetle banks. Kelly's already talked about barriers, and here's another one around, you know, in the bottom left. And how are we buffering our water courses just to stop that movement of perhaps some of those more plant protection products that can move across the surface. And the bottom right one is you know, with heavy rainfall, you can see this is the Eye Brook Reservoir on the River Welland, and you can see the Eye Brook reservoirs in the centre there, and you can just see around, I think this is in October in a couple of 3 years ago, the amount of soil that's coming down, and that's probably because we just haven't got soil cover, and that's our shop floor that's disappearing into that water course. So the next slide. So just to pick up on where things can help, I think the use of agri-environment for soil management, we're going to see things like soil standards coming up in future sustainable farming incentive. Current agri-environment schemes allow for much more land sharing. So the map on the top was our previous higher level stewardship application, mainly based around the edges of our fields. We're growing many more things in the field, so we're land sharing rather than just land sparing. So this means things like herbal lays and fallows, low input cereals perhaps on some of our land, because it is marginal, and I accept that on highly productive land the pressure to produce off it is there, but we're looking at the longevity of those soils and those production systems. So my second to last slide, Tammy, if we go on here, I've just put a few things up here which might come out in discussion. We need to find an economic model for this sustainable food production. You know, our highly productive grade 1 and 2 soils do need to have options on them, or they need to be decided, are we producing food off them, or are we putting something in? If potentially there are issues there around the environment, how are we going to address these very highly productive soils? And that leads on to what's the cropping, and also what's the tenure of the land. You know, if there are multiple crops being grown with different you know, farmers or contracts being grown from different growers, you know, does that soil get the attention it's needed as we go through those rotations? You know, George also alluded to root crops and you know, things like sugar beets and things that are growing under the ground as well. Other growers have found ways of strip tillaging in there. And how are we going to look after those high organic soils if they're disappearing? How can we perhaps, you know, can we rotationally flood them or re-wet them for a little while and put them back into production? And also, you know, there are different systems for different soils. There are different challenges. So broadacre crops will have a lot of different issues compared to high value crops and the role for livestock in there, or stockless grass systems, fertility building. I also mentioned earlier on is soil activity, always good. Sometimes people would prefer to have a bit more of an inert soil rather than have lots of functioning going on, for, as I mentioned. And we're going to come under increasing pressure for active ingredients and nitrogen use efficiency in the future. And I think getting better use of those and getting a more efficient use of those is going to be really, really important in the future, as is the environmental principles that will come in the Environment Bill, where especially runs around the polluter pays principle. You know, we are going to see much more pressure on urea, on ammonium nitrate, on the environmental protection. So I think as an industry, we've got a fantastic opportunity to address those, but also look forward to perhaps making the most of carbon and biodiversity. And my final parting thought is that most of my challenges on this farm have always come with weather, and it's too wet most of the time, and then when it's not too wet, it's too dry, but then I wouldn't be a farmer if I wasn't talking about the weather. So these challenges of changing weather patterns are really important. And my final slide is really where to look at some information. So, you know, AHDB have done a lot of work just recently in the last 3 or 4 or 5 years on their Great Soils project. So I would signpost people to go and have a look at that. And I think there'll be much more work being done in this area in the future. And the agroecology website, so Farming Without Labels, looking at soil management and very much covering a lot of the subject matter, showing best practice from around the countryside. So I think I'll call that a day there, Tammy, and hand back to the studio.
Thank you, Phil. I'll just stop sharing. If all the panel could turn their cameras on and rejoin, I will check the chat for questions. You may get away scot-free, who knows? So, George, do you do a full field till when you rotate your till rows, or do you just swap your till rows? That was quite hard to say.
No, I don't generally do a full field till. I would say that's still ongoing as to whether I always reuse the same cash row, cash like cropping row, or move it over. I would guess long term I'd probably alternate, because the bit in between the rows probably better or easier soil to work after 2 or 3 years than one next to it. But that's sort of an ongoing, I wouldn't say I have a rule for that yet.
Thanks for that, George. That was from Jane. And to Kelly and Becky from Simon, do you think the water buffering standard in the Sustainable Farming Incentive will deliver less sediment and better water quality in watercourses?
Yes, I'll start this and then Kelly can add in as well. I think, yeah, undoubtedly it will, because it's that kind of payment for public goods, isn't it, really? I think there's a lot of evidence to show that buffer strips do and can intercept the flow, and kind of the bigger the better. I read a paper recently where I think Christo inputted into it that kind of said that for a curb in particular, a 20-metre buffer zone was kind of the most effective way to reduce that overland flow. And I think because our trials have shown that it does move, and it can move as water, you know, in periods of heavy rainfall, then it kind of supports that view. And also the water buffering standard involves you doing like an erosion assessment, so similar to how Kelly and I went out and used alert maps to figure out where does the water run in this field. It would be a similar thing on a field by field basis. So again, it's kind of putting the measures in the right place. I think the good thing about the sustainable farming incentive is that you can pick and mix some different options. So it could just be in high risk fields that of you put in those options, and then in other fields of you can pick and choose from a suite of other options. So if you aren't having to do all of one thing, which I think is good and practical.
Kelly, do you want to add to that?
I think Becky's answered that perfectly. You know, the question was, you know, would it support? And it certainly looks like it will. So, yeah.
Tammy, could I just come in there?
Yes, Phil, of course.
Yeah, I think it's really important about encouraging farmers to uptake these buffer strips to keep water cleaner or to stop movement of soil. But I think it's not just the financial aspects of it as well. The system has to be practically implementable as well. So not just the buffer strips, but you know, if there is multi-layering of standards and things like cover crops and then soil protection zones. Just trying to think of one other one as well, cover crops and herbal lays, for example. But parts of the rules make it difficult to bring it in for a whole system, a rotational around the farm. It gets very complex for growers to understand when actually encouraging the whole system change is we've got to be very careful that we don't microanalyze every option there is and say, well, it's only applicable in this situation rather than that, when we're really encouraging the whole process.
Yeah, good point, Phil. So I can't see any other questions in the chat. So if I've missed one, please repost it. But I'm going to be a meanie pants and ask each panel member the same question. Remembering that South Lincolnshire is some of the most productive food producing area of basically the United Kingdom, which public good, if you had land here and you had a business here, which public good do you think you would focus on within South Lincolnshire? So I'll do it in the order of you spoke. So George, you're up first.
And a public good is what?
Well, the 6 public goods are clean air, clean water, adaptability for climate change, dealing with environmental hazards like flooding and drought, thriving wildlife, including plants. Obviously, people forget plants are part of wildlife, beauty, heritage, and people engagement.
I would probably go for thriving wildlife because it covers a lot more than the others, which are reasonably specific. Would be mine.
Okay, thanks, George. And what would you go for, Becky and Kelly? I could probably guess.
Well, I think obviously from a water company perspective, then clean water, you know, being part of the South Links Water Partnership, you know, clean water would have to be high up there, definitely. But I think, like George, you know, we farm in South Lincolnshire, and I think you do assume that it's all kind of, you know, bulb growing land and it's all veg growing land. But actually, there are some patches where actually it's probably better suited to grassland. So perhaps the more wildlife, you know, hedge options or like a long-term lay, and kind of introducing livestock back into those kind of areas which do sit wet. I think would be quite a good option on the farm in South Links. You know, it isn't all grade 1, although most of it is. I think if you can integrate the hedgerow options and the lower import options on the worse land, you know, the heavier and wetter land, I'd say.
Great, thanks, Becky. Kelly?
I think it was a horrible question, Tammy, for a start. I think it's very difficult to pick one, isn't it? Because as always, there are linkages between each of them. So actually prioritising one is always very difficult to do. As Becky mentioned, from a water company, I would have to pick the clean water. But I also think that it has huge benefits for lots of other things, as we've learned over the 6 years that I've been with Anglian Water, you know, with our focus being on that. But actually, you know, there are huge benefits for wildlife, for healthy soils, that have real heavy links into that clean water element.
Thank you, Kelly. And Phil?
Yeah, no, I think you also have to give some recognition for the fact that highly efficient, productive food production is pretty good, because it's pretty good for the environment. You know, if we're getting more efficient at it and we're producing the same from less, and George has alluded to how he wants to reduce his inputs, then that needs to get some recognition, and it probably will in the likes of cleaner air and perhaps some of the net zero aspirations. I think water storage is always is one that, you know, some parts of Lincolnshire have had issues with over the last few years, and I think, you know, certain places may well be able to find water storage or relief storage. Now, that's all right, and unless it happens to be your farm and a highly productive farm, but there may well be some pinch points that could be recognised there with a proper compensation scheme right at the beginning, not one that develops with flood relief halfway through it. And I think the final one is I'd really go for the well-being one around diet and healthy foods, and potentially, George, I'm looking forward to the ecotourism as well. So when it opens up, yeah, no, I'd be up for coming along there.
Thanks very much.
Might be a little while.
So we've had a question in. Oh, you thought my question was hard. Woohoo! Here we go. We've had 500 hectares intensive South Lincolnshire arable farm currently receiving through basic payment scheme around 100k. How would you suggest this funding removal could be replaced by ELMS options with very little natural environment features currently in situ? Anybody want to tackle that?
I'll start by saying I think it's going to happen. The signposts are that it's going to happen, and I think, you know, possibly some of the land sharing options may well be good. You know, if soil is disappearing and there are ways of putting parts of the farm either reflooding or regrassing or whatever, that may well be options. The difficulty is what the gross margin looks like comparison with continuing. But it may well be that if some of those things that come in the Environment Bill about polluter pays in, they may well slightly change the goalposts. So I think it's the writing is there. It's how businesses adapt that to try and get that win-win, because I think that's what we're trying to do here. It's not is this farming against and some of the feedback from the pilots on the sustainable farming incentive has been two sides to a story almost, you know, sustainable food production and an economic model versus conservation and environmental responsibility. What we need to do is have them go hand in hand. Yeah, I think I didn't really directly answer that, but there was a few thoughts to give some others time to think.
Becky, you've come off mute.
Yeah, I was going to quickly say this is something that we've thought about, having a farm in South Lincolnshire and having the BPS, and kind of wondering what the next step is. So for us, we sought advice from Brown & Co and went down the ELMS route. So we went back into stewardship again after a break of a few years. And there are some options like the well-bred mixes, so like AB9, AB15 and AB12 that do or can over like 5-year rotation actually pay quite well compared to a cash crop. And obviously those options were put on land which is kind of wetter, next to watercourse, land that isn't the high yielding land anyway. So that's how we looked into it. And the second option is similar to what George is sort of doing, so diversification. So I think ELMS isn't going to replace BPS entirely. You have to look for other options. So that's our two methods, having ELMS as a source of income, and I think it's the right thing to do anyway, but also looking for other opportunities for the farmers as well, because I think it is hard because there isn't the hedges there, there isn't the ponds there, and trees like elsewhere. So you have to look for other options. And for us, it was the wild beer mixes and the 2-year legume lays.
And George, do you want to add anything?
I mean, our BPS, I think we've gone into mid-tier, and which I think that question's from David, and he's on a lot different land to me with a lot more high value cropping than me, so it's hard for me to comment. But I think we're about 20%. If we lost BPS today, with mid-tier payments, a new carbon scheme we've just gone into, would be about 20% down on the overall. If we got we're 20% down on the overall figure. So if they removed it tomorrow, we'd be 20 to 25%, I think it is. So I think it's possible to get back to where it was, but whether some of the things I've done would be less profitable than David's silt, they might well be. And so it's not necessarily relevant what I'm doing to what David's doing, because it's much higher value cropping than what I can do at the moment, if that makes any sense.
It does, George. Lizzie's just asked, what carbon scheme did you go into?
There's a Danish company, very briefly, a group of farmers got together and said, if we don't do something about valuing soil carbon to farms soon, it will become state policy. It will get, the value will be sort of stolen away. So they put a lot of money in, and they've actually got an ISO accredited carbon trading or accreditation system for farms, which is now approved, and it's they're lobbying this with Brussels and et cetera, et cetera. So basically you have to follow their principles and follow their rules. And then if you see a soil carbon increase, or if you cover crop, if you keep bare land covered for certain amounts of time, and I won't go into every single rule and regulation that's to do with it. And it's not too restricting, actually. It's more restricting being in some of the other government schemes than they're in this. But they will then, at the end of the year, online on a portal, they'll issue credits, and I could sell those to them, or I could sell those to Virgin Atlantic to keep their jet in the air, or BP to keep digging oil, or sucking oil out of the ground. Doesn't matter who it is, that credit is an industry standard credit, just like a ton of wheat, you can sell it to anybody. It's another commodity. Whether that carbon trading offsetting thing is right or wrong, I'm in the middle on that, but nevertheless, as a farmer improving soil health, if somebody is going to put money in my bank for doing what I do anyway, of course, why would you not do that? So this would be my answer.
Okay. And to go back to David, I think people need to understand the environmental land management scheme, as Becky and others have alluded, will not be your only answer to replacement of basic payment scheme payments. You are going to need to diversify in regards to how you see where funding comes from, and I will touch on that in my presentation in a minute. Basically, I'm talking about the need for stacking and blending finance. So you may get some of the money through agri-environment, through the ELMS scheme, but you may also get for your natural capital assets. You may also get funded through either water companies or housing developers or carbon heavy industries to deliver natural capital ecosystem services from your land that helps pay. And I understand we still need to produce food. I am not saying that is exclusive to food. And we may even get to the point where people want to pay for British food at a decent price, but we'll see. So thank you to the panelists. I am now going to go into the presentation on the actual ELMS test itself. I'm going to provide some context and cover what we're hoping to achieve through the test. So I will now screen share for my presentation. Can somebody confirm they can see that?
Yeah.
Excellent, thanks, Beth. Okay then, so I always think people should know who I am because I'm going to be talking for a while and also working with some of you. Some of you already know me, some of you don't, out in the farming land. The important thing to notice is I may go to my mother to get my hair cut, but luckily the hairdressers are open again. Phew. Also the seahorse necklace. I have loved nature since I was a child. It was not a choice for me, it was a calling. So I've been working for Lincolnshire Wildlife Trust since 2016. Prior to that, I worked on marine designation and marine industry processes offshore for Natural England nationally. And for those in the Fen, you may remember me from my Wash Estuary Project Officer days, where Paul Tammy and I used to coordinate a farming group across the Fens around the Wash hinterlands. Prior to that, I have worked in the private sector for environmental consultancy. And here's the really important thing: born and bred of Lincolnshire, done my hours grading Brussels sprouts and cutting collies. And overseas, I worked in basically the sheep, and I was a shepherd overseas. So Lincolnshire Wildlife Trust, who I work for, we own around 100 nature reserves across Greater Lincolnshire. So that is from the Humber down to Wash. There's around 75 staff, and we are heavily reliant on our volunteer basis. We are one of 46 wildlife trusts that work across the United Kingdom. So we do cover all elements of the United Kingdom, and between us we're heading towards, slowly heading towards 1 million members. All organisations have a vision, and the important thing to note is Lincolnshire Wildlife Trust cover land and sea. And if you think of South Lincolnshire and all of the rivers that are flowing out into the Wash, one of the most highly protected sites in the United Kingdom, then you understand why we're covering both. What we do on land impacts the sea. You may wonder, why are Lincolnshire Wildlife Trust involved with, may be seen as trying to engage the farming community to make sure they get what they require from the environmental land management scheme? Well, I believe by working together we'll achieve more for nature and do it in a pragmatic way, because nature is in trouble. There is no doubt that nature is in trouble. This Natural History Museum report basically said 40% of all insect life across the globe is in decline, which, if you think about your crops, insects are quite important for that. That's the doom and gloom bit, but we know we have expertise in the Wildlife Trust in bringing nature back. And here we have the greater water parsnip, which is a plant native to South Lincolnshire. And this was on the way out, but through a seed collection and plant propagation program, this plant has been brought back from being extinct in South Lincolnshire. And the really important thing to note there is just how many insects that plant is supporting. So we're involved because our 100 nature reserves across Greater Lincolnshire equate to, on a good day, depending on if we include the salt marshes that we look after for the MOD, or if we don't. Let's go with if we don't. We equate to about 0.5% of the whole of Greater Lincolnshire within our direct influence through land management. Therefore, we need to work with our neighbours to not only buffer our gems, our nature reserves, but to connect them. And it is through working with farmers and other land managers that we will achieve that across living landscapes. And none of this is new. I mean, the most recent last 10 years, this landscape scale approach to nature's recovery has been talked about, particularly since the Sir John Lawton review that was published in 2010. And the most important thing to note is bigger, better, more joined up, so that nature reserves and core areas for wildlife are not islands. And from that, and it is never too far away from my hand, I have it in my hand as I speak, is the 25-year environment plan, which was published in 2018 by the government. And it is the first time a government has come out and said, nature is in trouble, we need to do something about it. It also sets out various other policy drivers. So the policies within the 25-year plan consider things like doing more for nature through a net gain approach, land management. So this is where environmental land management scheme is actually mentioned in terms of a policy framework. It talks about needing to look after our soils, particularly our peatlands, and how we manage land in regards to woodland and managing flood and coastal erosion risk. It clearly sets out policies around recovering nature. It's not, this is a really fundamental change in regards to language. It's not about conserving and preserving, it is about recovering nature. So bringing nature back from the brink. And how we connect people due to a myriad of evidence saying how much better our health and well-being is if we are connected to nature. And it has a series of policies around that, and also policies around tackling how we use our natural resources, how we reduce the impact of pollution and waste after we've used them. And of course, within the environment plan, we are an island, and it speaks about how we manage our seas so they remain healthy and biologically diverse. And we are an island on a blue planet. So within the 25-year environment plan, it talks about the United Kingdom being a game changer in how we manage the environment as a whole. This will be majorly underpinned by the Environment Bill at present. It was going through Parliament, but a small pandemic got in the way. The bill will be reintroduced in the autumn session, and at present we are expecting it to get royal assent and become an act by the end of this calendar year. Within the Environment Bill as it stands, and hopefully within the Act, it sets out what environmental principles our nation will be legally adopting. So, for instance, polluter pay is in there. It also sets out how we'll improve the natural environment. And this is a really good point for you, David, in regards to your question earlier. It sets out that there will be mandatory biodiversity net gain in regards to development. So this is an opportunity for land managers to think about how they may engage in that process. I will talk about biodiversity net gain much more in the interactive sessions. Also underpinning the Environment 25-year plan is the Fisheries Act, which did get in towards the end of last year, and of course the Agricultural Act that came into law in November of last year. Within that, it clearly sets out the requirement for environmental sustainable farming, and that there's going to be a transition period from all of the policy that we knew previously as being part of the European Union to transitioning through to being the United Kingdom in regards to setting our policies. And that starts this calendar year and runs through to 2027. There's going to be various support mechanisms in regards to basically agriculture, and the transition plan sets this out. There'll be funding around productivity and innovation and technology. There'll also be funding around woodland specific grants. But this is where we see environmental land management scheme coming into its own. And DEFRA wants this to be a co-designed scheme so that it meets the needs of business whilst meeting the need of delivering against the 25-year plan. And the term that is being used is public money for public goods. Now, in the interactive session, I go into giving examples of what a public good might mean in regards to being delivered on your land holding. But the 6 public goods that Environmental Land Management Scheme will consider funding outcomes towards are clean and plentiful water, clean air, protection from and mitigation of environmental hazards, such as flooding and drought, mitigation and adaptation to climate change, which leads to thinking about soils and carbon, thriving plants and wildlife, and beauty, heritage, and public engagement. So on land holdings, you have what we call natural capital assets. You have your soil, you have water, you have air, you have various wildlife species. All of these provide an ecosystem service. So if you've got insects on your land, they are likely to be pollinating your crop. That is an ecosystem service. And that crop then delivers a societal benefit of food, let's say, food that's been delivered locally in the United Kingdom. And the Environmental Land Management Scheme wants to build our natural capital assets and deliver public goods. There will be 3 tiers, one of which has been announced, and there were invites to apply to be a pilot for the Sustainable Farming Incentive, Tier 1. That closed this week or last week, sorry. My memory's not the best at times. And there are 2 further tiers, which we will be exploring through this ELMS test. So local nature recovery. This is about creating nature recovery networks in a local area. The targets will be defined by working with people in the know in that local area. And then there's also landscape scale recovery. So local, I've not seen a definition necessarily of what local is, but landscape scale could be the whole of the Fens, which covers Cambridgeshire, Norfolk, Suffolk, as well as Lincolnshire. Or up in the north of the county, we have the Humber Head levels, which cuts across to Nottinghamshire and Yorkshire, and we also have a test up there. So that is landscape scale and what services you could recover in that landscape, and it would involve working with your neighbours. So that's the policy drivers and context. But what does that actually mean for the South Lincolnshire tests and trials? So nationally, DEFRA invited back in 2018 applications for tests and trials for the ELMS scheme. And then in 2019, there was a second phase of applications where they said they wanted 6 elements considered and looked at. So the themes for phase 2 applications are land management plans, the role of advice and guidance, spatial prioritisation, collaboration, payments, and innovation in delivery. So within this test, We don't have to address all 6, but we need to be answering questions around these topics. And within your information packs that you should have received for today, you will have received a copy of Annex A that sets this out in more detail. So back in 2019, Lincolnshire Wildlife Trust, on behalf of 2 major landscape partnerships, applied for 2 tests, one up in the Humberhead levels and the one we're talking about now, the South Lincolnshire Water Partnership area. Both reflect a landscape scale approach and the need to work together. So the South Lincolnshire Water Partnership area, this is not a fixed boundary, it is an indicative boundary. You can see covers basically quite a lot of the South Lincolnshire Fens area, focusing on the South 40-foot and River Glen catchment. So where the water comes off the limestone in the west of the Kesteven area and drops down into the Fens. So the main things to note around this test is DEFRA wished us to look at, when they looked at all the phase 1 applications, they had very few through from highly productive food production areas. So that is why we applied for the Humberhead and the Fen area of South Lincolnshire. And they particularly also had a gap in their knowledge around horticulture. Through this test, we need to engage not only with agriculture and horticulture, but also other types of land managers. Now, what does that mean? Well, it could be a local public authority, because many of our local authorities own land. It could be other environmental organisations. We have nature reserves in this area, and so does the RSPB, and other organisations will do. So we will be directly looking to work with the farming industry, but also other land managers. We want to, through the interactive sessions, think about which of those 6 public goods are most relevant to South Lincolnshire. We want to establish a technical working group of land managers to support our steering group, and I will go on to who's in the steering group. And between us, we have to design a natural capital assessment for the whole of the area and build tools to help land managers in that area translate the assessment to their land holdings. And then we're going to talk to other potential buyers of those natural capital ecosystem services. And David, again, going back to your question, this is where we will be talking to, for instance, housing developers who are likely to have to deliver mandatory biodiversity net gain. They may not be able to deliver all of that on their own land holding where they're doing the development. So what are they going to be willing to pay to go off-site to deliver their mandatory biodiversity net gain? So we're going to have conversations around other sectors. So it might be the housing sector, it might be business park developers, it might be the water companies, because they need to ensure that public water supply is plentiful. We will be having conversations with multiple sectors about what may they be willing to pay and how would they see a market working so that an individual land manager could honestly and transparently stack payments of agri-environment public funding with their funding to try and address how they make it financially work for their business. So stage 1 is where we're at right now. It came to an end at the end of March of this year. It involved employing new members of staff because I have to cover the whole of Greater Lincolnshire. So we have Bethany Everton and also Joe Finlow, who are working on both of the ELMS tests. And we will be working with the South Lincolnshire Water Partnership. We've established a steering group which involves experts in and about natural capital, about biodiversity net gain and trading potentially water resources. So we have the Environment Bank, the Greater Lincolnshire Nature Partnership. LIAT is basically the University of Lincoln. The Rise Home Gang, so we have Isabel Wright and Sean Coots out of Simon Pearson's department supporting us. We have Simon Fisher, who's on the call today from the NFU, and Steve Muncaster from Water Resources. And it was to come up with how we were going to deliver this workshop, because originally we were going to do it with food and drink, but obviously we've had to go virtual due to the pandemic. The next stage will be delivering this workshop and writing it up and what we learn from it. And then to establish the technical working group of 15 land managers. We need you to support us co-design this whole process so that it's user-friendly and DEFRA take on board what we say. We'll already started a literature review of how various natural capital assessments have been undertaken across the United Kingdom and overseas. And we need to formally write that up so we can understand how to inform a South Lincolnshire one and what tools possibly we need to develop so it's useful to people. Then through September, we'll write up what that method's going to be and start to collate practical information about how we develop that to be a tool for land managers. And by January 2022, we will be going out to full consultation on the assessment that we undertake for South Lincolnshire through the latter part of this calendar year. This will be a chance for all land managers to say, you've got it wholly wrong, or you've got it wholly right. That fits with our land holding. They'll be able to comment on if our sort of proposed tools and guidance and advice is helpful. And the reason why you would want a natural capital assessment in place locally is to help you inform your land management plan that you're going to require to be part of any tier within the ELMS system. Because this will help identify local priorities and local goods. We'll take this assessment out to the other sectors and talk to them about what ecosystem services potentially land managers would be interested in selling in South Lincolnshire, and we'll start to gather information off them about what would they be willing to pay and how would they see that market, that trade happening? What sort of platform would be required? And then after that consultation period, we'll obviously produce a report of all the feedback we've had, and that's what gets fed back to basically DEFRA by the end of financial year, i.e. March of next year. So the next steps for you, basically we are right at the start of engagement. So we have the 3 interactive sessions today and tomorrow. You only have to join one. It's the same session. We're just trying to make it as accessible as possible to all people. So there's one at 3 till 5 today, then one in the morning tomorrow from 8 till 10, and then one in the early evening tomorrow from 5 till 7. We will be asking for applications to be on the technical working group of land managers, and also we will be coming out and asking questions throughout the whole of this time. I am very aware of stakeholder engagement fatigue, including around elms. So we will make it as simple and easy as possible for you, because we understand your time is precious. And I would really recommend, if you're not on the technical working group, to make the effort to comment on the consultation we'll be coming out with in January, because it's a tool that you will be able to use to engage with environmental land management schemes in application process, particularly for tier 2 and tier 3. And potentially it will enable some foresight around what other potential buyers are out there. And at any time you can call for a chat with us as a team. So I mean, Joe, Beth and myself, plus the steering group. I'm born and bred Lincolnshire. I know farming's important. I'm a pragmatist, but I'm part Viking. I need nature to be brought back on a personal level, and we need, as in the organisation that I work for, Lincolnshire Wildlife Trust, it is what we care about. But we understand that farming and delivering sustainable food for the United Kingdom also has to be part of the Lincolnshire makeup. We are not asking you to stop employing people and stop producing food. What we're asking you to do is work with us and innovate around that so that we can deliver for people and wildlife. These are not mutually exclusive. I truly believe they can go hand in hand. What I want from you going forwards is to think about the natural capital assets you have on your land. So I want you to continue to grow food, but I want you to build more resilience if you haven't already, or if, like with George, he's already on this journey, more resilience around wildlife, around your soil, around water. Challenge yourself to see things differently. There are technologies coming online right now and in the last 5 years that will make things easier. I sat on the EU leader funding boards that basically, you know, there was funding available for getting directional drill kit and other kit. There will be funding for this sort of stuff coming forward, announced over the next year or two. Be willing to have a go. Work with your neighbours. That doesn't mean you have to give up your commercially sensitive information. It does mean that you will achieve more together. We have learnt that through the farm cluster and farm facilitation approach. We will deliver better soil, better water and more wildlife through working together. I think all farming has to, for its own benefit, let alone societal benefits and benefits for water, are going to have to come up with more integrated pest, soil and water management planning, because I do not think it can remain as it is in regards to what we use and put on our land and take from our land and still produce food. And here's the important thing, we need to monitor it and celebrate. Farming is not the woe of why we are where we are. I have said this time and time again. Society has chosen certain paths and farming has delivered that. Society is now saying biodiversity and the climate change crisis is important. And I know you are capable of coming on that journey again. You will deliver what is asked, And we are here to help you deliver that. So do not feel alone. Because what I want from my home county is that we deliver the nation's food, we deliver the nation's water, and we deliver the greatest nation's recovery programme. And I think we need to do it in the next 10 to 15 years. So I want all of us to work together because we'll do it better together. Thanks for listening, folks. Please note the ELMS email, which was also in your information pack, along with Joe and Beth's mobile number, and that's my direct line, because obviously under the pandemic presently, we are doing a lot of working from home. So I will stop sharing my screen and see, Nicola, yes, I can share, we can share basically the presentation, so that's fine. If anybody has any questions, please place that in the chat and I will happily answer it. The important thing is the things, if you haven't already booked for one of the interactive sessions later today or tomorrow, then please email us and we can get you added to one of them. And that is where we will start to prioritise what is it South Lincolnshire should focus on in regards to public goods, what are our natural capital assets, and what services can we deliver for people and wildlife together. And that does include food, people. So anybody got any questions? Because in the chat, oh, here we go, Thomas, we haven't received the action plaque. The information pack had the agenda and all of frequently asked questions. So if that hasn't successfully reached you, I will say this is the first time we've been using Zoom for such a big event where we're trying to share information through it. We will get that out to recipients after, and I apologise that it didn't arrive beforehand. We will get that out, Thomas, so you have our contact details as well. If not, it is 3 minutes past midday, which those who know me and know I can talk, that's not bad going for me. I'm on time. Thank you for listening, everybody. I think the next 5 years are going to be full of uncertainty, but if we work together, we can find the answers. And this is the start of that journey. Be open, be honest, work with us. That's it, folks. And hopefully see you all later or tomorrow in the actual workshop sessions. Take care. Thanks for joining. Get in touch if you can't make it to the sessions. Cheerio.